The last topic of chapter 7 is about the singularity. As you know, the singularity issue is difficult to understand. Anyway, in here we will show two planar example. Anyway, I want you to get some insight from this simple example. Okay, let's consider the Poba linkage. Let's consider the Poba linkage. As you know, the Poba linkage has the 1 degree of freedom. Okay, here the theta is the input and the pi is the output. So by manipulating the every variable, then we can write down the pi as a function of theta. On the contrary, theta as a function of pi. Okay, maybe you remember the solution of exercise 2.25. In there, we can get this equation. Actually, in here is pi, alpha, and beta, and gamma as functions of L1 through L4, the link variable. Anyway, if we know the link variable, then alpha, beta, gamma can be determined automatically. Then we can describe the function of pi as a link variable and theta. Okay, so theta is the input, pi will be the output. In here, let's illustrate the trajectory of the pi as a function of theta. Then we can know that this bold curve can be obtained as a solution of this equation. Okay, let's choose one configuration such as 0 theta and pi at this point. Maybe this point will be equal to the 0 theta, so it is the 0 like this, and the pi angle, so like this, inverse way. So maybe the linear structure will be obtained, linear mechanism will be obtained from this configuration 0 theta and pi at this point. Okay, if this configuration approaches from along with this curve, okay, at this point we should determine this mechanism can be moved to the like this or not, or upward or downward. Maybe it will be corresponding to the left side or right side. So we cannot predict upward or backward. Okay? So this kind of point is called as bifurcation. The branch of the curve meet the bifurcation. Okay? Let me read this sentence, the entire sentence. Let's highlight the essential feature of the closed chain singularity using the two simple example as mentioned before in the first slide at the beginning time. Okay, closed chain singularity can be divided into three categories: actual singularity, computation space singularity, and end-effector singularity. Okay, you should list up the three kinds of singularity because those are very important for the parallel mechanism. Okay, so the existence of uniqueness of the solution of this form to this equation above depends on the link length L1 through L4. In here, distinctive feature of this figure is presence of bifurcation. Okay, some configurations such as the 0 theta and 0 phi the 0 L2, this one, and pi angle of the pi. This is the 0 theta. Okay. the pi s of pi, okay, 180 degree, okay. So this kind of a linear mechanism will move to upward or downward if a small perturbation applied to this mechanism, okay? Like this, we can determine at the bifurcation point. Bifurcation is a typical example of singularity, okay? Okay, let's extend the Pobal linkage mechanism to the 5-var. Maybe you know the 5-var has the 2 degree of freedom, okay? This one must be the 5-var, first and second and third and fourth and fifth, okay? Like this, it has the 5-var, okay? It's very easy to calculate the body kinematics, loop constraint, okay? Aaron times cosine and sine in the x direction and the y direction, okay? L2 times theta 1 plus theta 2, okay, in the x and y. Okay, like that, like this, we can determine the end point of this one. So we have this equation. It will be equal to L5 in x direction and 0 in y direction, okay? So it has the two equation using the 4 variable. So the function, nonlinear function, will be mapped from the 4-dimensional space to the 2-dimensional space, real space, okay? So it must be the 2-dimensional case. 2-dimensional. The solution, the compilation space, will be described using the 2-dimensional surface in alpha or configuration, okay? In the previous slide, the sum point can be French to the left or right, or upward or downward. Okay, this kind of a bifurcation point can be extended to the self-intersection of the surface. The line is extended to the surface in the case of the 2-dimensional space. Okay? At such a point, the constraint Jacobian lose the length. It is called as configuration space singularity. Okay? We have 2f. This is the f1, f2. Okay? We have the 4-dimensional variable, so round f, round theta 1, round f1, round theta 2, round f1, round theta 4. Okay? Round f2, round theta 1 through round f2, round theta 4. Like this, we have the 2x4 matrix. In here, we can calculate length of this matrix. The length is smaller than the 2 degree of freedom number. Those kind of computation will belong to the singularity. Okay? It depends on the length deficiency. Okay? Okay, if you know the length deficient matrix, at that time we said we have the compilation space singularity for this mechanism. Okay? Okay, in the case of 5-var, we can obtain this kind of linear structure or linear mechanism. L1, L2, L3, L4. Okay? L1, L2, L3, L4. Okay? L1, L2, L3, L4. L1, L2, L3, I'm sorry, the L1, L2, L1, L2, L3, L4. Like this, the linear comparison can be obtained using some angular variable. Okay, actually, this computation belongs to compilation space singularity because these structures, it can move upward or downward. Okay. On the other hand, it can be moved like this. This is also. Okay, so those computation has the bifurcation. Okay. Actually, this kind of structure, this kind of singularity is dependent on the actuator location. Okay. So let me deal with in detail. Okay, let's consider another configuration. L1, L2, L3, L4. Let's attach the actuator beginning part and the last element. And then we will apply the outside torque like this, tau 1 and tau 2. What happened in this mechanism? This mechanism will be the structure without moving. Is it right? It belongs to singularity. Okay? This kind of concept, this kind of singularity is said to be a non-degenerate actuator singularity. In order to remove this kind of singularity, it's very easy. The actuator location can be exchanged to here, such as the actuator here. At that time, this singularity disappeared. So actuator singularity is dependent on the actuator location. Okay. On the other hand, L1, L2, L3, L4. Here, okay, let's control at the static point. Okay, 0 theta 1 and 0 phi. Okay, let's maintain this compilation, but the L2 and the L3 move like this, rotate like this, upward or downward, left side or right side, without any actuator displacement. Okay, this singularity is called as degenerate actuator singularity. Okay. In some case, singularity does not have any movement. It is called as non-degenerate actuator singularity. Okay, the structure is constructed, but the remaining joint can move freely. This constraint is called as degenerate actuator singularity. Okay, so I think it's better to memorize these two configurations: non-degenerate, degenerate actuator singularity. Okay, as mentioned before, if you want to remove the actuator singularity, at the time we should relocate or replace or move the actuator location from here to there. Okay. Okay, for both degenerate and non-degenerate actuator singularity of the fiber linkage, relocating one actuator to one of the other three passive joints will eliminate singularity. Okay. Okay. In short, that is to say, the actuator singularity can be moved by relocating actuator location. Okay, in the previous lecture, we have dealt with the 3 rag. Okay, do you remember that? Theta 1, theta 2, theta 3, blah blah, theta 5. Like this, we can write down the first leg and the second leg. Okay, pi 1 through pi 5, the third leg. Okay, the psi 1 through psi 5. Like this, we can make the example to be general. Okay, in here, we have obtained the J1 minus J2 zero matrix, J2 minus J2 plus J3, and then theta 1 dot through theta 5, maybe the last element psi 5 dot, okay, will be the 0. Okay, by choosing the column vector according to the actuated joint, then we can write down HA by collecting the column vector corresponding to the active joint. The remaining joint is collected to form the HP matrix. In general case, HP has the P by P matrix. In the previous example, it belongs to R2 12 times 12. Actually, the HP belongs to RP times P. Okay, so this matrix, okay, maybe you know the QP dot is obtained minus HP inverse HA QA dot. Okay, if the inverse exists, the passive joint velocity can be determined automatically using this equation. Okay, so the length of the HP, the maximal length will be the P, smaller than P. At that time, the Q has the actuator singularity. Okay, so in this case, we should relocate actuator position to from one to another. Okay. On the other hand, the entire matrix H, the length of the H is smaller than P, then this computation is called as computation space singularity. Okay. Like this, we can divide the two singularity. Okay. This matrix is singular. That computation belongs to actuator singularity. Entire matrix lose the length. That computation Q belongs to computation space singularity. Okay. Maybe let's read the last sentence. Note that under this condition, HP also singular. So entire matrix is singular. At that time, HP must be singular. So computation space singularity is rather than the bigger concept compared to actuator singularity. Okay. Please read the remaining sentence. Okay, this is 5R. Okay, first L1, L2, L3, and L4. Okay, let's choose the end effector at this point. Okay. Okay, let me choose this one. Okay, if we choose other point, okay, it's okay. But I will choose end effector at the corner of the triangle. This class, it must be the singular because maybe the L2 case, L1 and L2 are extended to the the linearly extended like this. In the case of the R2, this kind of computation belongs to singularity in the case of open chain. Those concept is applied to the parallel mechanism. So the extending the link will belong to singularity. Okay, at this point cannot move to this side. Is it right? Because this is the maximal length of two link. It can move here like this, but it cannot extend it to this side. Okay, so it depends on the end effector location. If you choose end effector at this point, okay, like this, it does not have end effector singularity because it belongs to L1 and L2. So it can move anywhere. So the last class, the final class of singularity depends on the choice of end effector frame. Okay? If you should be careful to choose the end effector frame. Okay, this figure shows the fiber linkage in an end effector singularity for given choice of end effector location. Okay, I explained it before. Let me skip. The end effector singularity are independent of the choice of the actuator joint. Okay. End effector singularity only dependent on the location of end effector. Okay. In this case, choose any valid set of actuator joint QA such that the mechanism is not at the actuator singularity. Okay, so we have talked about the compilation space singularity, actuator singularity, and end effector singularity. Okay, in the case of the end effector singularity, if you want to remove the end effector singularity, then we just move the end effector frame to here to there. Okay. Okay, you have the homework number 6 about the chapter 7. It does not have many problem in the exercise, so I will choose the 5 exercise. 7.1, 7.3, 4, 7, 8. The due date will be the next Friday, May 28. Please upload it as a PDF file or email me, including the attached file.